This folder could fit quite a lot of quality revision content in it. So let's get started. This is the 6th chemistry video, and it's going to be on rates and the extent of chemical change. So, the first thing we need to know is the actual equation for how we can get this. So, the rate of equation equals the amount of reactant used divided by the time taken. So, the amount is always in grams or centimeters cubed, and the rate is always in grams per second or centimeters cubed a second. So there's another equation for this, which is amount of product formed over time taken. So whichever one of these two you're given, you can use to find the rate. Or you can, of course, rearrange the equation to find the time taken or find the amount of either. So next, let's move along. So this topic, it contains a lot of practicals, which I won't be talking about. So some of this might get a bit random, but I've managed to focus most of it in this area. So factors that affect reaction rate. So temperature affects reaction rate. As the temperature goes up, the reaction rate also goes up. And due to there being more heat energy given into the reaction, that means more kinetic energy is given to the particles, so the particles can travel quicker. And the quicker particles travel, the more likely they are to collide. So, and then if there's more collisions, that leads to more energy due to collision theory, and the more energy makes it speed up. So yeah, it's kind of similar, but concentration leads to the rate going up. For a similar reason, they're more likely to collide. However, it's slightly different because there's the same amount of things, same amount of particles in a smaller area than there would have been. So the smaller the area there is, the more likely they are to collide with each other, as they're constantly bouncing around the sides and bouncing off the edges. So, factors that affect reaction rate. Let's go through some more. So, surface area. So the rate goes up when the surface area goes up, so as more particles are able to collide, so collisions are more likely, because there's more actual particles that can collide with it. So small objects have a bigger surface area to volume ratio, because the bigger things, they don't always have a big surface area, because it depends on their volume as well. It's comparing the two together. And smaller things often have bigger surface areas because there's less mass around the point. So yeah, catalysts. Catalysts are, fun fact of the day, often made of transition metals. They lower activation energy, so less energy is needed for the reaction. So that's what activation energy is. It's the amount of energy needed for a reaction to take place. So if we lower that, if we lower the amount of energy needed, then it will happen quicker because the time will go down. So the time, as we can see from this equation, if the time taken goes down and we divide something by something that's lower, we will get a higher result for the rate of reaction. So it all links to that equation, really. So next, this is where it starts to get a bit weird. So graphs. So the reaction is complete when the graph levels out or plateaus, if you're incredibly pretentious. Plateaus. Anyway, steeper line. So if there's a steeper line on a graph, that means a reaction has taken place quicker. That also leads to the graph leveling out quicker normally. So one thing you may be asked to do is find the gradient of a line. So basically you just got to draw a triangle from the line. So as you can see here, I had that black line already there, and I drew those blue lines myself to make a triangle. So the bigger this is, the more precise it'll be. So this side is the change in y. So you've got to take the highest point of it and minus the lowest point of it, and that will give you like the change, because it's the difference between the two. And then once you've found the changes of both, then you do the change in y divided by the change in x to get the gradient. I could do a full video and sort of stuff like that, maybe some math stuff, I'm not sure. So then let's move on to reactions. So different types of reactions. There's exothermic reactions, where heat exits or is given out. So it makes the outside temperature increase because heat actually leaves the thing that's reacted. And then there's also endothermic reactions, where heat is taken in, so the outside temperature decreases because that heat energy is concentrated on the object. It's absorbed by it almost. Probably makes no scientific sense, but okay. So reversible. Reactions can be reversible. Any of these can be, if something exothermic is reversible, then it turns into endothermic on the other side, but let's not get into that. So reversible. So a product can become a reactant. This is a symbol for it. It basically means that when something's already reacted and given you products, the products can re-become reactants, and if they react, it will turn back into what was originally the reactant. So this cycle can repeat many times, just through different processes. Well, through the same process. It's just a cycle that doesn't stop. So next, let's move on to some variables. Oh, great! I just did a programming thing. This will get confusing. Anyway, dependent variables. So dependent variables are the ones that are measured. So they're the ones that you're trying to find as results. They're affected by independent variables, which is the changed variable. So the changed variable is the thing that you actually change in the experiment to see what results it produces, what difference it makes. So the dependent is obviously affected by the independent, because that's what you're trying to find by making differences. Then the control variables, the things that are kept the same. So, but an important thing you may be asked is for key control variables. That is like, has to be specifically important control variables that could change the result. And you don't want them to change the result, because that would make the results of your experiment not really valid. If something else had affected the dependent, then that wouldn't be good at all. So that was the rates and extent of chemical change. I think the most important bit of this video is definitely that bit and this bit. So it's definitely the actual factors in that. I don't know if the rest, well, the rest definitely links into it, but I don't know if it's like fully about this. So, okay, goodbye.